Okay. Oh, Tim, what's that? I did. Maybe not. Anyway, okay, so the agenda for this evening is me to chat briefly, because I have to go somewhere else, unfortunately. And then I'm going to just put OpenCL in context, mention about where we are, where it comes from, who works on it, that sort of stuff. And then Tim is going to do all of the interesting stuff around OpenCL 1.2. Well, in technical about OpenCL, he's going to talk about OpenCL 1.2, which we just released yesterday, was it, with the press release? And it's available on the website now. And
basically, yeah.
Yeah, and so Tim will talk about the new groovy features and that putting that book out a date because it doesn't have 1.2 features. But anyway, and then excitingly, we're going to have OpenCL in action, and we've got two people to talk about that. We've got Simon McIntosh Smith from Bristol University. He's going to talk about what they've been doing in docking codes for medical and docking, do they call it? And then where's Ben gone? Ben, he's going to talk about all the work that he's not allowed to talk about because he works at OpenCL. No. He's going to talk about some of the stuff that they've been playing with OpenCL. No, you're not?
No, but it'll be fun.
Okay, so Ben's not going to talk about that, he's going to talk about OpenGL.
Lies and deception.
Lies and deceptions. Oh yeah, normal military stuff then. Yeah, okay. Okay, and then we're going to talk a little bit about, Tim I suppose will come up and do this again, he's going to talk a bit about what's the future, what's going to happen beyond today and tomorrow. And then finally, Tasman here from Samsung is going to talk about WebCL and how that relates to other products and other offerings from the Khronos group. Perfect. So, okay, so usual pitch. We have GPUs on one side. GPUs are quite popular here now. We have CPUs on the other side, and they are merging together to create this intersection of fun that is called heterogeneous computing. And of course, if anyone's seen it, just this week, Altera announced that they have an OpenCL implementation for FPGAs. So I don't recommend it because I work for AMD, but if you don't, then you could replace GPU with FPGA, and it's going to be great. That's quite an exciting thing because I think that really is the interesting thing about OpenCL is that it's not a proprietary standard. It's open to anyone sticking their device out there, and it has its verbosity and things like that. But the great thing is you can stick in all sorts of weird and odd devices underneath it. FPGA is just being one of them, and GPUs being another. And so it's this kind of fusion of things in the middle here that OpenCL allows you to program. It's a great heterogeneous program. So it's a big idea, but actually it's quite a simple idea. And Tim, of course, will tell you that OpenMP had this idea a while back. But it turns out that if we run a kernel, which is this thing on the right-hand side, actually we'll take the loop, we'll say, okay, let's not execute the loop, let's execute every single instance of that loop, potentially concurrently, which is what we're doing on the right-hand side here. We're going to stamp it out as a little kernel, and we're going to run that individually, the SPMD style thing, and then you get what's called a data parallelism execution. And so, we take the normal thing, you can stick an OpenMP pragma over there, but we don't do that because that would only distribute it today, at least, over a many core CPU, whereas OpenCL will let you distribute it over a many core CPU. No, but also GPUs, FPGAs, any device you choose to put in there. And so that's the great thing. It's very much the same execution style model. You have an n-dimensional grid and you execute it over it. And each point in the domain represents this instance of this kernel. I'm not going to go into that. You should have come to our brilliant tutorial that we did on Sunday, and you'll learn all about that if you didn't. Otherwise, there's great stuff online to find out more about it. It's all based on C99, so if you're not a C++ fan, then shame, but you can still do it. C's there, and there are other wrappers and plugins for different languages to use that. And as I say, I think it is exciting that you can imagine doing FPGAs, deriving, actually generating gates from this program on the right-hand side and executing it. Okay, so there's lots and lots and lots of people and companies, moreover, that are involved in it. It was not the work of one person or an individual. It's the work of many people, many companies that sponsored it, and I'll let you work out which one's missing. Oh no, actually it's there. I'm not sure it's supposed to be there. Okay, so maybe there isn't one missing.
Whoa, yeah.
Yeah.
Well, I didn't know we were allowed to put
How did that get in there? Anyway, we'll let you work out which one that might be. Okay, quickly moving on before anyone sees it. Okay, so the OpenCL milestones, we started way back before that, but in June 2008, the working group was kind of formed, as a whole, and it was kind of announced that we, along with that other company that we must have mentioned, were starting to look and forming a new standard to handle compute. And then in May 09, December 08, which was SIGGRAPH Asia, the first release was made of the specification, and then later on in an 18 months cadence we got to June 2010 and SIGGRAPH, the summer SIGGRAPH one in the US and in Los Angeles actually, and the 1.1 specification release, and 18 months along we finally broken the graphics connection and come to supercomputing and have announced the OpenCL 1.2 specification at supercomputing. And I think times are changing, you know. OpenCL is not just seen as a graphics-based API anymore. There's lots of resources. That book in particular, buy lots of copies of it, it's great. Well, actually, AMD give you away 3, so just go to the AMD booth and you won't have to buy it. But, you know, and so it's free for developers. You know, there is no licensing, everything you can do with it. There's no worries about it. You can get the spec. It's not just going to be randomly updated and those sorts of things. There's a bunch of information at the Khronos website. The Khronos repository, the OpenCL repository, has all the header files, specifications, anything like that. You can get that. There's a nice reference card, which we don't... Have you got a reference card to hand out?
No. You don't have any?
No. Oh. Okay, we don't have the reference card.
You don't have any?
No. I'm sorry about that. We haven't got the 1.2 reference card, but there's a lovely reference card. You can download it from the website. There's lots of online reference pages. And there's a busy, active developers forum where each of the companies generally take a time, a slot, and it just kind of rotates around, so you'll get different feedback from different people, and then some of us just hop on and do that. And Tim's going to show something very exciting, almost as good as the book. Can I hold it up, Tim?
No, not yet.
Not yet? Why not?
Keep going.
Oh God, you can't, that's unfair.
Keep going.
I was
No,
going to
no,
do it. Okay, not yet.
Not yet.
And of course, you know, there's AMD have a developers, AMD.com website. You can find out lots of stuff. You can download our implementation there. Intel have the softwareintel.com site. There's, you know, you can download their SDK, which works on many core CPU today. And you can go to NVIDIA, developer.nvidia.com, and you can download their OpenCL implementation. If you have Lion on your laptop and you download Xcode, you'll get OpenCL. Just comes with it. That's part of the thing. And there are other implementations, IBM's, for example, that works for the power and the cell. And I think that's probably the only one, Big Bender's ones, but there are others available. There's some open source work that's going on too. OpenCL book, as you can see, there's a brilliant book at that far end that Tim will tell you all about, which we're co-authors on, the blue one. And there's a brilliant book, one in from this end, which I've just been giving out. You know. And there's these other 2 books, which I'm sure are great too, but I have to say personally, I wasn't involved in them and haven't actually looked at them, so I can't comment on those. But there's a great books are available now. Go to Amazon.com and you can get them. Okay. Okay, that's it.